How is the periodic table arranged by electrons? Have you ever wondered how the periodic table is organized? It is a fascinating structure that reflects the arrangement of electrons in atoms. Let's break it down in a simple way. The periodic table is arranged based on the electronic structure of atoms. This means it focuses on how electrons are organized around the nucleus of each atom. Each element has a specific position in the table that corresponds to its atomic number. The atomic number is the number of protons in the nucleus, and in a neutral atom, it also equals the number of electrons. Electrons are arranged in energy levels called shells. These shells can hold a certain number of electrons, determined by the formula 2 times the shell number squared. For example, the first shell can hold 2 electrons, while the second shell can hold 8. Each shell is divided into subshells, which are labeled as S, P, D, and. Each subshell has a unique shape and can hold different numbers of electrons. One important principle is the Pauli Exclusion Principle. This principle states that no 2 electrons in an atom can have the same set of quantum numbers. This means that each orbital can hold a maximum of 2 electrons, and they must have opposite spins. Electrons fill the lowest energy orbitals first, following what is known as the Aufbau principle. This filling order is essential because it determines the electron configuration of an element. The electron configuration influences the chemical properties of the element. The rows of the periodic table are called periods. Each period corresponds to the filling of electron shells. The first period has only 2 elements because the first shell can only hold 2 electrons. As you move down the table, the number of elements in each period increases as more shells are filled. The columns of the periodic table are known as groups. Elements in the same group have similar valences electron configurations. Valences electrons are the electrons in the outermost shell, and they play a key role in chemical reactivity and bonding behavior. This is why elements in the same group often exhibit similar chemical properties. Historically, the arrangement of the periodic table began with atomic mass and chemical properties, thanks to Dmitri Mendeleev in the 19th century. However, in the early 20th century, scientists like Henry Moseley and Niels Bohr showed that the atomic number and electronic structure provide a more accurate arrangement. Moseley's work established that atomic number, rather than atomic mass, should define the order of elements. Meanwhile, Bohr's model explained how elements are grouped based on their electron shells. This electronic arrangement leads to the periodic law, which states that the properties of elements recur periodically when ordered by increasing atomic number. The structure of the periodic table is essential for advances in chemistry and physics. It allows scientists to predict the properties of elements and discover new ones. Understanding how the periodic table is arranged by electrons is crucial in fields like materials science, chemistry, and physics. It helps in predicting how elements behave and bond with one another. This knowledge is foundational for modern technologies that depend on specific elements and their properties, from semiconductors to pharmaceuticals. The periodic table is not just a chart. It is a remarkable milestone in the history of science that captures the relationship between atomic structure and elemental properties. It reflects how our understanding of matter and energy has evolved over time.